Good morning, guys. Today we're going to do the very last thing with simple wavelength and frequencies. I want to remind you, amplitude tells you how loud or how soft a sound is, how bright or how dim a light is. Frequency tells you the note if it's sound, and it will tell us the color or type of light when we're dealing with light. There are special sound frequencies for different notes. We've gone through this. There are some frequencies that we cannot hear because they are too rapid, and there are some frequencies we cannot hear because the oscillations happen too gradually. Same is true of light. Most types of light our eyeballs are not sensitive to. They're either too low a frequency or too high a frequency. The only ones we can see are in the range of 4.3 e to the 14th to 7.5 e to the 14th. Anything outside that range is not visible to the human eye. It turns out that we really only have 3 different kinds of cells on our retina. These are called cones, and the cones are, like I said, of 3 different types. One that's sensitive to long wavelengths, one that's sensitive to short wavelengths, and one that's sensitive to medium wavelengths. And each of those special colors that trigger those cones are called our primary colors. Most people don't know what the primary colors are. So you'll notice on this Jeopardy clip, the person's going to get it wrong.
400. Sarah?
Blue screen photography, which lets us transport an actor to a place like Tatooine, is possible because the base material in color film is sensitive to these 3 primary colors.
Okay, so if you were on Jeopardy, what would you pick as your 3 primary colors? Do you know what they are? Are they the correct ones? Well, let's see.
Mary?
What are red, yellow, and blue?
No. David?
What are red, green, and blue?
Yes.
You'll notice that this person made a very common mistake. She thought the colors were red, yellow, and blue. Yellow is not a primary color. The primary colors are red, green, blue. RBG. Okay, red, blue, and green are the 3 primary colors. Why are they the primary colors? Again, because in our eyeball, on the retina, we have cells that are sensitive to low frequencies, high wavelengths. We have cells that are triggered by high frequency or low wavelengths, and then we have cells that are triggered by medium wavelengths or medium frequencies. Our brain processes these as red, blue, and green. Realize this is only something that happens in our brain. Red, blue, and green, and all the other colors are not really something that we could say are real. They're just the way that our brain reacts to certain frequencies or wavelengths of light. So when you look at the spectrum, again, we have some cells in our retina that are triggered by this type of light. We have some cells that are triggered by this type of light. And then we have some cells that are triggered by the higher frequency or lower wavelengths lights. When you guys think about mixing colors together, I want you to realize that most of your life, most of your time in art class, you are mixing paints or markers or crayons. They are not sources of light. These are dyes that have pigments in them that subtract colors away. So do not use your experience from art class to understand what is really happening with light. Okay, so for instance, if you're in art class and you see blue, realize that the painting is not giving off blue light. If you were to turn off all the lights in the museum, that painting would turn pitch black. You wouldn't be able to see it. It does not produce blue. What happens is when the white light of the museum hits it, that area that looks blue takes away red and green. Blue reflects off. And it's that reflecting off blue that then hits our eye and triggers those cones in our retina that are sensitive to blue light. If you have a spot like this that's white, all three colors, the red, the green, and the blue, all reflect off of that. All three areas of our eyeball are triggered, and our brain processes that as white. But these colors are not real. They are just things that are triggered depending on how many of the cones are triggered. If only the high frequency cones are triggered, we'll see it as blue. If only the low frequency cones are triggered, we'll see it as red. If the medium cones are triggered, we'll see it as green. And if they're all triggered equally, we'll see it as white. Okay, it turns out that you can make all kinds of different colors, millions upon millions of different shades of color, by adjusting how strong the red, the green, and the blue is. So if you were to look at a Rubik's Cube and you look at the red side is going to have just low frequency light bouncing off of it. The other frequencies are all absorbed. The blue end, that is going to reflect only the high frequency light. It's going to absorb the red and the green. And finally, the green will only reflect the medium frequencies. It will absorb both low frequencies and high frequencies. When you get to things like the yellow and the orange, things become a little more complicated. And that's what you're going to learn today, is how to produce those myriad of different colors. Okay, so in this case, I created a color that some people call salmon. Okay? It is a color that looks like this. And you'll notice to create this exact shade, you need to have the red triggered by 100%. You need the green triggered at a level of only 50%. And you need the blue triggered at a level of 40%. I don't want to give away too much more because the activity today is going to ask you to figure out how to produce all the different kinds of light, okay, based on the red, the green, and the blue. But again, remember, red, green, and blue, why are there three? Because there's three kinds of cones on our retina. One for low frequency, one for high frequency, and one for medium. And depending on which cones are triggered, our brain will process that as a color. Those colors, again, are not real. They're a figment of our brain trying to make sense of what's happening with these chemical reactions that are triggered on the back of our eye by certain frequencies of light. So anyway, without going into too much more detail, I'm going to ask you guys to try the activity on the Google form and submit it when you're done. Best of luck.